Alrighty then, welcome to another episode of Metallist Math. This is going to be part 2 of a continuing series on ACT practice tests. So we're going to go over the ACT math stuff that you might see on there. Give you some tips on how to eliminate answers that are definitely not right, and just some strategies on how to approach these problems. Let's go ahead and dive right in. Alright, so it says a rectangular lot that measures 125 feet by 185 feet is completely fenced. It says, what is the length in feet of the fence? Alright, so we got a rectangular lot. So we got 185 and 125. Okay, a couple different ways you can do this. So basically you're going to have 185 here as well, and 125 here as well, because you need to go around the thing. Sometimes they'll call this the perimeter. Okay, so then what you're going to do is you can either just add these guys all up, or you can say I'm going to do 185 plus 125 and then double it, because we have that here, we also have that here. So again, let's break out our calculator. So clear it out and we say, all right, so we go 185 plus 125. That gives me 310, and then we're going to do that again. So 310 times 2 is 620. So that's our guy. All right. Let's check out another one here. Okay. So this one, they want the equivalent expression. So quite frankly, these little parentheses right here, we don't really need. So what we're going to do is we're going to multiply the A out front by all the stuff inside. So we've got AB, A times B is AB. Get rid of that guy. A times negative C is minus AC. Plus AC, just a C. Because what happens a lot of times, people remember to multiply the first term by the guy outside, but then not the rest of them. Okay, so we're down to these two. So the last one, we got A times D, so that's AD, not just plain D, and there's our guy. So see how we can walk through there and we can just eliminate answers and get to where we need to go? Sweet. So let's move on. Okay, so here we've got 6x minus 3. I'm going to write that here so we can work with it. And then 5x plus 7. Okay, so if you're not really into the whole let's add 5x to both sides and that kind of stuff, here's another way to think about these. So you can move any term from one side to the other side simply by switching the signs. So I have negative 5x over here. So if I bring him over here, he's going to be plus 5x, and then we have plus 6x, right? So he's gone from this side. Now we can do the same thing with the negative 3 here. So if I bring the negative 3, because we want x guys on one side, number guys on the other side, right? So bring him over here, he becomes positive 3. Okay, then we can start combining some stuff. So over here, I've got 5 plus 6, that's 11. Bring the x along. Equals, we have 7 plus 3, that's going to be 10. And then we always, when we get x's on one side, numbers on the other side, we always divide by the number in front of the x. So that solves this thing for x. So we get 10 over 11. Not a particularly pretty number, but we didn't think we were going to get one anyway by looking at the answers. All right. So that's just some basic algebra. But like I said, you can do the whole if you're more comfortable with, I got to add 5x to both sides. I got to add 3 to both sides. That's fine too. I just wanted to show you maybe a little different view of that, maybe help you out with that. All right, so this one says, what two numbers should be placed in the banks below so that the difference between the consecutive numbers is the same? So it's saying if I start with 13, add something to it, gives me the next number. Add something to that number, gives me the next number. Add something to that, I get 34. Okay, so there's a fancy way to do this. But the real thing is we want the numbers to be the same distance apart, right? So let's check it out. So if I go from 13 to 19, that's going up 6, right? But then if I go from 19 to 28, that's going up 9. So that's not our guy because it's not consistent, right? So next one, if I go from 13 to 20, that's going up 7. If I go 20 to 27, that's also going up 7. Might be onto something. But then if I take 27 and add 7 to that, then I am going up from 27 to 34. So this is our guy. Okay? And like I said, there's a fancy formula for that, but it takes too much time. This is easier to do. All right, so this guy, they tell us the cube root, or not the cube root, they tell us x to the third is 927. Okay? So then they want to know, what is this expression? So the first thing we need to do is figure out what x is. All right, so calculators are different on this one. So what we want to know is we want to know what is the cube root of 729. So in this particular calculator, I could do 729, and then this is raising it to a power. Okay. Now, as it turns out, the power for a cube root is not 3, it's 1 over 3. So then we can write that in here by saying 1 divided by 3. And then, I should put a parenthesis there, hang on. So like I said, different calculators, so you got to work with this stuff. Oh, it came up, no, that's not right. Okay, something went wrong, hang on. So again, different calculators, this is a good example, right? So 729, and then we're going to raise that to the, I need a parenthesis here, because 1/3 power is 1 divided by 3. Okay, and then hit equals again. So it's 9. So what that's saying, to double check yourself, you can say 9 times 9 is 81, times 9 is 729. So if I multiply 9 3 times in a row, I get 729. So the upshot of all this is that x equals 9. Okay, so we go up here, so then we've got x squared. So if you have x squared equals 9, or I mean if x equals 9, then x squared equals 9 squared, which equals 81. And then the square root of x is the square root of 9, which equals 3. And since we're adding these two guys together, we add these two guys together, and I get 84. So there's our guy. All right, guys. Well, once again, I appreciate you all listening. We will continue this series in the not too distant future. And again, like I say, like, comment, and subscribe. If you're into heavy metal, check out my Metallist channel. That's THEE Metallist. And we'll see you all next time.